In this video, we'll take a look at orthogonal complements. The problem is to find a basis for W perp where W is the given span. First, let's make sure that we're familiar with the definition of W perp. Well, we say W perp for short, but formally the name is the orthogonal complement of W. And W perp represents the set of all vectors x such that x is orthogonal to our first basis vector as well as our second basis vector. Let's take a closer look at these two equations here. Let's say the components of x are x1 through x4. This first equation says that x1 minus 5x2 plus 2x3 plus 3x4 equals 0. And if we write that up in the form of an augmented matrix, our basis vector is just going into the first row, and we've got a 0 on the right side. The second equation here, we just end up with a second row in this augmented matrix. Again, the basis vector is leading us to these coefficients here, and we've got a 0 on the right side. So the problem really comes down to now solving this specific system of equations. So let's put our matrix into our REF. We've already got a 1 in the upper left. Let's take row 2 minus twice our pivot row. In the bottom row, that's going to give us 0, 11, negative 3, negative 5, and then a 0. We can move down and to the right, and this 11 here is going to be our new pivot. So let's take row 2 divided by 11. And then finally we can take row 1 plus 5 times our pivot row. So we can do a little bit of calculation down below if we like. To get this entry here, we're going to have to take 2 minus 15 over 11. That's 22 over 11 minus 15 over 11, which gives us 7 over 11. For our fourth entry in the top row, we'll be taking 3 minus 25 over 11. So that's 33 over 11 minus 25 over 11 gives us 8 over 11. And then finally we've got the 0 on the right side. So we've now got our matrix into our REF, and I'm just going to erase these side calculations here. So remember, we're trying to find the vectors x that are orthogonal to both of these original two basis vectors. So it makes sense to call our variables x1 through x4 here. In the first row, we've got a leading 1 in that position there. From the second row, we've got a leading 1 here. So there are two columns which are going to lead us to two different parameters. Let's say x3 is equal to s and x4 is equal to t. Top row tells us that x1 plus 7/11 of x3 plus 8/11 of x4 is equal to 0. And if we move both of these terms over to the other side, we'll have the sign change. We'll also use the fact that x3 is s and x4 is t. So we can write x1 is minus 7 over 11 times s minus 8 over 11 times t. Second row tells us that x2 minus 3 over 11 times x3 minus 5 over 11 times x4 is equal to 0. Again, we can move both of these terms over to the other side and we'll have a sign change. And again, using the fact that x3 is s, x4 is t, we get x2 is equal to 3/11 s plus 5/11 t. So I've just kept the original problem and our setup written up over here, and I've just made a little bit more room so that we can finish up the problem. So let's continue our work over here. Let's express our vectors x in vector form, meaning we'll have a vector times s plus a vector times t. Looking back at x1, we said it was minus 7/11 s minus 8/11 times t. x2 was 3/11 times s plus 5/11 times t. x3 was s and x4 was t. So at this point we can use these two vectors here as a basis for W_perp. But remember, when we're working with a basis, that we're free to multiply our basis vectors by any non-zero multiple. So we may want to multiply through by 11 just to clear those fractions. Another alternate answer would be a first basis vector of -7, 3, 11, 0, and a second basis vector of -8, 5, 0, 11. So I think this right here would be the best possible final answer. If you want to check your work, you could look back at the original setup up here and just check that each of these two basis vectors here is orthogonal to both of the original basis vectors. So you can check all four possible dot products here, check that they all come out to 0, and then we're reasonably assured that we haven't made any arithmetic errors throughout the problem.